Now, another class of differential equations that can be solved explicitly is called linear differential equations. So here is the definition. Well, notice that traditionally, linear differential equations, they are not written in the form where dy dt is in the left-hand side. Of course, it's the same thing to just write it as dy dt equals minus p of t y plus g. Well, g is also a function of t. So here is an example. This is my p of t. This is my g of t. So here is another example. Of course, here we can easily rewrite it. So we can divide it by 3 squared. And then we are going to get dy dt plus t over 3y equals 1 over 3t squared cosine t. Well, here is one more example, because we can rewrite it as y prime plus 0 times y equals cosine t. So now p of t is 0. Well, here, notice that now the independent variable is x. And so we can write it minus 0.01 y equals 0. Now g of t is 0. And p of t is minus 0.01. So it is actually independent of t, and strictly speaking, it should be p of x, because now x is the independent variable. And here is one more example. Notice that some of these equations are also separable. So how do we solve linear differential equations? Let me go through an example, through the first example. Okay. Well, what is special about this? So notice that in the left-hand side we have y, and we have dy dt. But at the same time, the corresponding multipliers t cubed and 3t squared, I mean, if you stare at them, you will notice that the derivative of t cubed is exactly 3t squared. Right? So these terms, they're also related. One of them is the derivative of the other one. So that's the left-hand side of our differential equation. It looks like this. We have t cubed dy dt plus dt cubed dt times y. But this is, according to the chain rule, is nothing else but the derivative of the product t cubed y. And this equals to cosine t. Well, thus our differential equation tells us that the derivative of the unknown function, which is t cubed y, is cosine t. It means that that function itself, t cubed y, is the integral of cosine t dt, which is sine t plus constant. In other words, y equals sine t plus constant over t cubed. So now notice that unlike separable differential equations, here all the steps are completely rigorous, and from the steps it is absolutely clear that by doing this we found all solutions of these differential equations, but it's not probably clear how we can generalize this to use it to solve all possible differential equations, because the reason we were able to do it is due to the fact that the left hand side of our original differential equation has this nice form. So it is something times the derivative of the unknown function plus the derivative of that something times the unknown function. And then, therefore, it's the derivative of the product.